Hello, I am going to present Chapter 7 about the Arduino programming course for industrial use. In this chapter we will see an introduction to the different types of communications available in PLCs based on Arduino and that can be achieved with each of these. In the next chapters we will go into more detail to each of these. Arduino boards have different pins through which different types of communications can be performed. For example, we find the SPI pins. We also have the serial TTL and E2C pins. We see in the Arduino Mega board that, like the Arduino Leonardo, also has some pins for SPI communications, although the Arduino Mega has more possibility of communications because it has many more pins for TTL series. This board also has I2C communication. The only thing that must be taken into account in communications with these boards is that they work at 5 volts. Now, let's see how the I2C communication method works. This type of communication consists of two pins, the SCL and the SDA. The SCL pin is responsible for making the communication clock, and the SDA is the data line or serial data. These lines need a pull-up resistance to 5 volts. Resistors can be connected in series without protection. This type of bus works by positive logic, which means that the high level means a logical 1 and the level low a 0. The SDA and SCL pins can be observed directly on an Arduino board and are also available on all PLCs. This type of communications allows the creation of the serial data bus between different equipments. Basically, we have a main controller that is defined as master. To perform this master function, we can directly use any of the PLCs that we have available. This is because each of these has an integrated Arduino board that will be the bus's main microcontroller. On the other hand, we can also connect a slave to another PLC. In fact, up to 128 elements can be connected. While it must be taken into account that this type of communication is very important to take in consideration the distances between elements, since it is a type of short distance communications. The next type of communications that Arduino allows us is the TTL serial. Basically, we have two pins that make up this type of communications. One is the RX with a function of receiver or reception, and the other pin is the TX with the function of transmit or transmission. Communication through the pin RX and TX directly from the Arduino board allows the use of the TTL communication systems and works at 5 volts, which is the voltage which the Arduino Leonardo and Arduino Mega board works. These pins also allow us to perform other type of communications more common at the industrial level. For example, you can use RS485 and RS232. When we connect two devices through the RX and TX pin, due to the function of each of these pins, it implies that the receiving pin of a device must be connected to the transmission pin of the device with which it is connected. The same goes for this other equipment. This limits the communication to connect only two computers between them. Using the Arduino pins directly, this is called serial TTL, and the PLCs we have available as we can find in the industrial serial RS232 communications. This type of communication is also identified through the RX and TX pin, and one of the features that differentiates it from the serial TTL is that it is necessary to add extra circuitry to the Arduino. The usual thing is to add among other elements as the MAX232 or one of its models, since there are infinity of them and different manufacturers. What is important is that if we have a communications with the RX and TX pins directly from the Arduino, they cannot be connected with RX TX pins are prepared to work as serial RS232. With the RX TX pins, you can also perform another type of communications, commonly called RS485. As with the RS232, extra circuitry is needed to adapt the original signal from the RX-TX to the RS485 standard. Unlike the TTL serial and RS-232 serial using RS485, more than two devices can be connected to each other. In this case, the RS-TX pins are renamed pin A or positive or B or negative. The signal adjusted by our hardware allows us to create a master-slave bus, just like we have seen with I2C, although in this case the connection distance are more longer, since we can talk about 1,200 meters between nodes. With the RS485 communication, several points must be taken into account. First of all, Arduino allows you to do RS485 with different pins. Not only RX and TX pins are destined for that purpose. By doing this, the key value communications could be set to be an RS485 communication by software. Now, using RX and TX to perform RS485, we get a communication by hardware, and this allows us to use an industrial communication standard such as the Modbus RTU. Another point that we have to take in consideration is that, unlike what we have seen in the TTL serial and RS-232, for the RS485 the connection will come to match the I2C. I mean that in this case we connect all pins A and B to each other respectively. This allows us to make this communication bus. From RS485 we will see that there is the RS485 half duplex and RS485 full duplex. The following communication system that we will see is the SPI. In this type of communications we will have different pins that we need to connect with each other. We have the MISO pin, MOSI pin. We also have a clock that will mark the rhythm of communication. In Arduino we have a pin reset voltage, which in this case are 5 volts and ground. This communication system also allows us to connect different elements, although it has some difference with the RS485 and I2C. In this case, each equipment is identified directly by software, giving an identification to each element. And the SPI communications, we have a master in charge of managing the entire network, and each element has a selected pin associated with it. This means that each element connected to the SPI bus will be read as the data that is sent by the bus when its respective pin select is set to high or low depending on the characteristic of this element. It is very important to note that each pin has its own select. This in the PLC implies that each of these select represents the use of a digital output. The usual thing is that you have to use 5 volts pins. There are certain types of common elements that are connected to the microcontroller by SPI, for example, by Ethernet. In fact, in the PLC, the connection of the communication board, where the Ethernet circuit is housed, has connection to an output for the Arduino board, as we will see when we see the Ethernet communication. Another type of normal communication will be to connect a module to use a memory card. In fact, this communication is usual to see in the different elements that are connected to the microcontroller in a printed circuit. To see what this type of communication represents and how each of the elements are connected or associated, we can understand the following. If we have a message sent by SPI where there are 4 different elements to this bus, each of these elements only interprets what is being said only when its select pin is selected. This, however, has a limitation, and is that you cannot send different messages at the same time, so we have to have an orderly methodology to send data through a system of communication by SPI. What can be done is to send the same message to several elements if the different models are previously selected. With all this, we will see how each of the communication systems are executed in the next chapter.